The moon is leaving the Earth. Every night, the moon looks almost permanent. It rises over cities, oceans, deserts, and mountains, glowing quietly above Earth like it has always belonged there. For thousands of years, humans have used it to measure time, guide travelers, shape calendars, inspire myths, and light the darkness before electricity ever existed. But the moon is not staying where it is. Every year, slowly and almost silently, the moon moves a little farther away from Earth. Not enough for the human eye to notice, not enough to change the night sky in one lifetime, but with instruments precise enough to measure tiny changes across space, scientists have confirmed it. The moon is drifting away from us. The number sounds small, about 3.8 centimeters every year. That is roughly the speed at which fingernails grow. But over millions and billions of years, that tiny distance becomes enormous. It changes the length of Earth's day. It changes the tides. It changes eclipses. And it reveals that the relationship between Earth and the moon is not frozen in time. The moon is leaving Earth, and scientists know why. The reason scientists can measure this is because one of the quietest and most brilliant experiments ever placed on the moon. During the Apollo missions, astronauts left special reflectors on the lunar surface. These devices are simple in concept, but incredibly powerful. From Earth, scientists fire laser beams toward the moon. The light travels across space, hits the reflectors, and returns to Earth. By measuring how long that round trip takes, researchers can calculate the distance to the moon with extraordinary precision. This is called lunar laser ranging, and it has been done for decades. The results show that the moon is slowly receding from Earth at about 3.8 centimeters per year. That distance is tiny compared to the moon's average distance of about 384,000 kilometers. But the important part is not how small the change is in 1 year. The important part is that it is real, measurable, and constant enough to reveal something deep about how Earth and the moon exchange energy. The moon is not simply floating beside Earth, it is locked in a slow, gravitational dance. The reason the moon is moving away has to do with tides. Most people think of tides as water rising and falling along coastlines. But tides are much more than that. They are the result of gravity stretching Earth. The moon's gravity pulls on Earth. It pulls slightly harder on the side of Earth facing the moon and slightly less on the far side. This creates tidal bulges, especially in the oceans. As Earth rotates, these bulges do not stay perfectly lined up with the moon. Because Earth spins faster than the moon orbits, the tidal bulge is carried slightly ahead. That small offset matters. The bulge of ocean water has its own gravity. And because it sits slightly ahead of the moon, it pulls the moon forward in its orbit. That forward pull gives the moon a tiny amount of energy. As the moon gains orbital energy, it moves it slightly higher, wider orbit around Earth. In simple terms, Earth's rotation is slowly pushing the moon away, but energy does not come from nowhere. As the moon moves outward, Earth's rotation slows down. Our day becomes longer, little by little, over enormous timescales. The moon's drift tells us something surprising about Earth's past. Long ago, the moon was much closer to Earth than it is today. That means tides were stronger. The moon looked larger in the sky. The Earth rotated faster. A day on early Earth was not 24 hours long. It was shorter. Over time, tidal friction slowed Earth's spin, stretching the length of the day while the moon moved farther out. This process has been happening for billions of years. It is not a sudden disaster. It's not something humans need to panic about. But it is one of the clearest examples of how even the most familiar parts of the world are changing. The moon feels external because our lives are short. But on the scale of planetary history, Earth and the moon are still evolving. The night sky we see today is not the same night sky ancient Earth had. It will not be the same sky future Earth will have. The moon's gravity is the main force behind Earth's ocean tides. As the moon moves away, its tidal influence slowly weakens. This does not mean tides will disappear anytime soon, but over extremely long timescales, the relationship will change. When the moon was closer, tides would have been much stronger. The oceans may have moved with far greater force, shaping coastlines, mixing nutrients, and possibly influencing early environments where life developed. As the moon recedes, tides become weaker than they once were. The sun also affects tides, so the oceans will still respond to gravity, but the moon's role will slowly diminish. This is one reason the moon is so important to Earth. It's not just a decoration in the sky. It affects the oceans, the rhythm of life, and the long-term motion of our planet. One of the most beautiful coincidences in the solar system is the total solar eclipse. The sun is about 400 times wider than the moon, but it is also about 400 times farther away from Earth. Because of this, the moon and sun appear almost the same size in our sky. That is why the moon can perfectly cover the sun during a total solar eclipse. But this coincidence will not last forever. As the moon moves farther away, it will appear slightly smaller in the sky. Eventually, it will become too small to cover the sun completely. We happen to live at a time when the moon is just the right size in the sky to turn day into night. One day, that will end. The moon moving away from the Earth may sound like a small fact, but it reveals something much larger. It shows that the Earth-Moon system is alive with motion. Even after billions of years, gravity is still transferring energy, slowing Earth's spin and changing the moon's orbit. It all reminds us that the universe is not static, that things that look permanent are often changing too slowly for us to notice. Mountains rise and erode, continents drift, stars age, planets shift, moons move. The moon has shaped the Earth in ways we often forget. It has stabilized our planet's tilt, influenced tides, and marked time for life and civilization. Without the moon, Earth would not be the same world. And yet the moon is not fixed in place. It is part of a long process that began when the Earth-Moon system formed and continues today, quietly, year after year. The moon is leaving Earth, but not in a dramatic escape. It is drifting away slowly, about 3.8 centimeters each year, pulled outward by the same tidal forces that raise and lower our oceans. The tiny movement carries a huge story. It tells us that Earth's rotation is slowing. It tells us that the moon was once closer. It tells us that our days were once shorter, our tides were once stronger, and the sky itself was once different. One day, total solar eclipses will disappear. One day the moon will look smaller than it does now, and far in the future, the relationship between Earth and its companion will be nothing like the one we know today. But for now, the moon is still here, still bright, still close enough to shape our oceans and our imagination. Still moving silently away, 1 year at a time. Maybe that's what makes it so haunting. The moon has been with Earth for billions of years, but even our closest neighbor is not truly staying. It is leaving us slowly. The only reason we notice is because science has learned how to measure the distance between love and time.